In order to get ready to start studying Chapter 9, Quadratic Functions and Equations, we need to work some problems that are going to be review problems for Chapter 9. Part of your review assignment asks you to work problems 25 through 27 on page 543. This video is designed to work those problems with you so that you can understand what the problems are asking and how you should respond. The learning target for this section is I can get ready for Chapter 9, Quadratic Functions and Equations. More specifically, what these concepts that we're reviewing are designed to do is help you to learn the following in Chapter 9. We're going to be studying about discriminants of quadratic equations, graphs of quadratic functions, vertices and axes of symmetry of a quadratic function, and solutions of quadratic equations. Question number 25 asks you to use your knowledge of the definition of a quadratic polynomial to make a conjecture about the definition of a quadratic function. Now, the word conjecture in mathematics means to make a guess, a really educated logical guess based on patterns and observations. It's very similar to the scientific hypothesis. And what mathematicians generally do is they make conjectures and then they set out to prove whether the conjecture is true or false. In our case, we're not going to be proving any conjectures, but what we will be doing is making the conjecture. So we want to have a conjecture about, well, what is a quadratic function? So recall from your previous studies that a quadratic polynomial is a polynomial that has a degree of 2. Has a degree of 2. So let's write some examples of quadratic polynomials. For instance, one quadratic polynomial might be 3x squared. Another one might be x squared plus 8. A third might be 3x squared plus 4x plus 8. Now recall that the quadratic polynomial that I wrote, the third one, this one, is in standard form and has values of a, b, and c. In order to change this so that I no longer just have a quadratic polynomial, but now I have a quadratic function, I'm going to take that polynomial and set it equal to f of x, like so. So I write it as f of x is equal to 3x squared plus 4x plus 8. This is a quadratic function because it is a function which includes a quadratic polynomial. Now, what we're going to be doing in this particular section is we're going to be studying these quadratic functions and their properties, ultimately so that we can graph them and then use them to model real-world situations. Now, the standard form for a quadratic function is the following. F of x is equal to ax squared plus bx plus c. And I have to put kind of a disclaimer on that, or a little caveat that says where a does not equal 0. And I want to explain to you why I have to say that a cannot equal 0. So think about it for a second. What would happen to this quadratic function if a is equal to 0? Well, if a equals 0, I would have f of x is equal to 0 times x squared plus bx plus c. And that means that the entire first term here would not exist, and I would just have bx plus c. Well, what type of function is that? It's not quadratic, it's linear, and would graph as a straight line. So when I write the definition of a quadratic function, I'm going to have to say that the quadratic function is f of x equals ax squared plus bx plus c, where a does not equal 0. Okay, let's continue on. Our next question, number 26, says, the graph of a quadratic function is a U-shaped curve that has an axis of symmetry. What do you think this means? So let's think about the term axis of symmetry. Well, symmetry is basically discussing or saying that two things look the same, or two halves look the same. There are many shapes that we have which have symmetry. Let's draw a quick triangle, like so. And if I draw my triangle pretty well, then it might contain an axis of symmetry. And in this case, the axis of symmetry would go right down the center, just like that. And basically what the axis of symmetry is doing is it's dividing the triangle into two parts that are mirror images of each other. So this section on the left is a mirror image of the section that's over here on the right. That is an axis of symmetry. So a quadratic function is going to be a U-shaped curve that has an axis of symmetry. So when I draw it, it's going to look like a U, and the axis of symmetry is going to float right down through the bottom, or right down through the center, and it's going to divide it into two halves that are mirror images of each other. That is an axis of symmetry. The axis of symmetry really helps us when we are graphing parabolas. It makes them easier to graph them. And by the way, that U-shaped curve there, you're going to hear me say this word a lot, is referred to as the parabola. So if you ever hear me say the word parabola, you know that I'm talking about the U-shaped curve that is the graph of a quadratic function. Okay, let's look at problem number 27. The following is an example of the zero product property. X plus 3, or the quantity rather, x plus 3, times the quantity x minus 4 is equal to 0. So x plus 3 must equal 0, or x minus 4 must equal 0. What do you think this means? Well, so let's think about this equation. This equation is a quadratic that is in factored form that has been set equal to 0. We're going to be working with these particular types of equations in Chapter 9. Now I want you to think about what does it mean for two factors to equal 0. So what if I gave you the problem 3 times 0 equals 0? Or I gave you this particular equation, 0 times 4 is equal to 0. Well, why is it that these two factors, 3 and 0, have a product of 0? Well, it's because one of the two factors is equal to 0. So what this zero product property here is saying is that whenever you have two factors that are being multiplied together, and those two factors are equal to 0, they have a product of 0, that either the first factor must equal 0 or the second factor must equal 0. So what I'm saying is this. X plus 3 is the first factor. It is being multiplied to the second factor, x minus 4, and the two factors have a product of 0. What that tells me is that one of these two factors has got to equal 0, because the only way to get a product of 0 is for at least one of them or both of them to equal 0. So either the first one can equal 0 or the second one can equal 0, but one of the two of them have to equal 0. Now that gives me a clue as to how I solve these problems, and we're going to actually be using this particular property to solve these types of equations in this chapter.